Okay, we're going to try to make a little video here and see how these work out, see if you like them. In this first video, we're just going to look at how moving a little signal around in time works, how we can figure out what it looks like after it's been shifted. So our little example signal will just be a little pulse with an amplitude of 1 between 0 and 1, and we'll call that S of t. And let's say what we're interested in knowing is what does S of minus t plus 3 look like. So if it just had the shift of 3, we know in this case it would move to the left. If it was just a minus t, we know it would be mirrored, but with the combination of both, maybe we're not quite sure what that signal is going to look like. And so the way I like to think about it is to look at where the original signal is doing something interesting and to say, okay, for in this case, for example, t equals 0, and to say, well, S of t is going to go from 0 to 1. And what we need to then understand is, look, it's the argument when it's 0, the signal is doing something interesting. And so now we have to just take it as the argument, instead of just t, this whole piece. Maybe it makes sense to rename that tau and to say, well, when tau equals 0, the signal is going to go from 0 to 1. So if we write that out, again, when tau equals 0, S of tau is going to go from 0 to 1. Well, what's tau? Tau is minus t plus 3. In this case, we're setting it to 0, so t equals 3. And so now we know our shifted signal is going to do this thing, go from 0 to 1 when t equals 3. Okay, when else does it do something interesting? Well, at t equals 1, S of t goes from 1 to 0. And if I look over here then at my new signal, my shifted signal, when tau equals 1, right, S of tau is going to go from 1 to 0. And so minus t plus 3 equals 1, or t equals 2. So now when t equals 2, it's going to go from 1 to 0. So there's my signal after it's been mirrored and shifted. It has an amplitude of 1 again, but there's now between 2 and 3.